In the name of God, hello dear students, welcome to Ferho's website. In previous lecture I solved some questions for you. Right now I'm gonna explain new subject, which is measurements of angles, right? Measurements of angles are divided into three, let's say measurements, three scales. The first scale is degree, the second scale is radian, the third one is revolution or rev. So degree, we have been familiar with degree so far actually. It's not new for us. Degree is very common. But these two actually other scales are new for us, right? We haven't been familiar with radian and with revolution as well. They are new, let's say, scales for measuring angles. The abbreviation of radian is RAD, rad. Yeah, read it, rad. The abbreviation or revolution is rev. Read it, rev. So we have three things. Degree, either let's say whether we have degree or let's say rad or rev. That's the old one, and it's very common for us. But in this lecture, because we are in grade 12, this is the last year of high school, we want to, let's say, read an advanced, let's say, topic of physics that focuses on, let's say, that focuses on radian and revolution, and especially radian, because radian is valid in SI. Radian is valid. Let me read the definition of radian. So what's radian? Maybe you, let's say, you heard this word before. Radian, right? You heard this word, but you don't know exactly what radian is. Right now, I'm gonna, let's say, explain radian for you. So what's radian? Radian is an angle whose arc length is equal to its radius. So S is equal to R. If the angle, right? If the arc length of the angle equals the radius of the, let's say, circle, so this angle is called radian. So what's 1 radian? Let me underline it for you. Underline the important parts. It says an angle whose arc length, look here, arc length, is equal to the radius. So I summarize it here within the parentheses. Actually, we have a condition. If S is equal to R, so the angle is equal to radian, and is approximately equal to 57.3 degrees. So radian has to do with degree, right? You can convert degree to radian or radian to degree, and vice versa, right? So what's the condition to achieve 1 radian if the let's say arc length balances the, let's say, if the arc length is equal to the let's say radius of a circle, is called radius. Let me draw an angle, and I want you to determine whether it's radius 1 radian or not. So this is the theta, right? This is theta. This is R. I say R is equal to, let me write it here, R is equal to 2 centimeter, and S is equal to 2 centimeter. I want you to determine the angle, whether it's 1 radian or not. So based on this condition, or based on the definition of radian, when arc length, right, and the radius of a circle are equal in magnitude, that's why we have 1 radian. So S is equal to 2 centimeter and R is equal to 2 centimeter. That's why we have 1 radian. Because based on the previous equation in previous lecture, and I told you this is the first, let's say, equation of your textbook, the first one, theta, we said that theta is equal to S over R. Right now, I want you to substitute these values here. Instead of S, write 2 centimeter divided by, instead of R, write 2 centimeter as well. So they cancel one another. They cancel out, and 1 remains. That's why especially about the angle. Actually, in physics, if the units cancel one another, we say that this quantity is unitless. And we say this speech here is as well for radian. For radian, no problem. You say radian is a unitless, but let's say in SI we use rad, right? We use rad when let's say when we deal with these situations, when we use this angle, actually this equation for finding angle theta is equal to S over R. Actually, we write rad after the number. So I can say the unit of angle of rotation is rad, and rad itself is a unitless, is a pure number. What does it mean, pure number? It's no dimension. It doesn't have any unit, right? So, and approximately I can say 1 rad is equal to 57.3 degrees. Memorize this number. Excuse me. I have seen several times, let's say, this value in national exam questions, but not exactly 57.3. Let's say I saw in a question of national exam that they changed the angle to the 53.7. You have to be accurate, right? Maybe you in the first, let's say, vision, you say they are the same. Let me read for example, let me write the question for you. For example, which of the following? This is the question of national exam actually. Which of the following? Let me write it for you. Which of the following is equivalent to 1 rad? Is equal to 1 rad, right? So which one is equal to 1 rad? The first one, for example, 57.3, 53.7, C, whatever, and D. Actually, I want you to, so I give you two options. Which one is right? I want you to, let's say, focus on the number and keep in mind that 57.3 is not 53.7. If you don't memorize it carefully, actually, you forgot the number exactly. I had a lot of students, they made the mistake, believe me, they made the mistake about this situation, and I want you to be very, let's say, accurate. Question, so we have a tip here. Radian is a pure number with no dimensions. I told you, radian is no dimension, has no dimension actually. It's a pure number. But it's exceptional. Actually, it's exceptional quantity. It's a little bit different from the other quantities. For example, in previous lectures, in previous years, let's say, last year or the year before the last year, especially in grade, let's say 10, we had index of refraction. And this index of refraction was unitless. We didn't write any unit after the number, but here I can say radian is different. Radian is a pure number, is unitless, but you use let's say rad after the number, even it's unitless, right? Number 9. Why is radian a pure number? Why? This is the question. Nice question. Answer: because it's the ratio of an arc length based on the equation. Let me write the equation for you. Theta is equal to S over R. Why do we say radian is a pure number? Because it's a ratio of an arc length, right? Arc length S it's a distance, to the length of the radius, also a distance. Thus, units cancel each other based on this equation. So, I told you, I examined it actually for you. If S is measured in centimeter or meter or whatever unit of distance actually, let's say, for example, S arc length is measured in meters and radius is measured in meters as well. So whenever you solve the problem, let's say units cancel one another, right? They counteract one another and nothing remains. But here, that's why we say rad is a pure number. It's a, let's say, dimensionless or unitless quantity. Let's move on to another question. We have a proof here actually, and let me tell you this. Let me tell the note actually. Because you are in grade 12, proof is not, let's say, it's not actually required for you. You are not supposed to read the proof and know the proof, but for, let's say, better understanding, sometimes we need to prove the equation. Believe me, I have a lot of students that told me actually, I have a lot of students, let's say in each year I, let's say, encountered these, let's say, situations. They come to me and say, teacher, we don't know what the origin of this rule is. We want to prove it for us. Whenever I proved that for them, actually, they understood the subject, they understood the equation, they could memorize the equation. And for me, as a teacher, actually, I've been teaching physics for 20 years, right? But I still have problem, believe me, with memorizing some rules. Let's say, sometimes I need to prove the equation to, let's say, to remember the equation. Believe me, and I'm a teacher. I prove the equation, and after that I remind the equation. Right? Let me read the proof for you. And proof has to do with this graph actually. We need this graph. That's why I want to, let's say, be in front of you. I want it to be in front of you actually. It says, when the length of the arc length is as the circumference of, so we have a proof here. We want to prove the, let's say, 1 rev is equal to 2 pi rad and is equal to 360 degrees. We want to find a relationship between the measurements of angle, right? Do the measurements of angle have to do with one another or not? Let's do it together. We have a proof here. But how do we start the proof? We start with a condition. We say that if the length, let me draw it with another color. If the length of the arc length, right? If the length means S. If the length, when the length of the arc length is as the circumference of the circle. Circumference means C, right? When S is equal to C, right? Theta is equal to S over R. Actually, we have a previous equation. We are familiar with this equation. Theta is equal to S over R, and I told you this is the first equation for your textbook, right? S is equal to theta is S over R. In this situation, I'm gonna, let's say, remind you a rule for circumference of a circle. Actually, circumference of a circle is equal to 2 pi r. I'm sure you know it, and you got it in mathematics, especially just for, let's say, reminding you this equation actually. Substitute this value right here in this equation. Theta is equal to S over R. instead of S, because we say S is equal to C, right? So S is no longer, let's say S. S turns to C. S turns to the, let's say, circumference of a circle. I want you to write the equation, write the value of circumference, which is 2 pi r divided by r. R cancels r, actually. And theta is equal to pi rad. That's why we started from this rule. We put, let's say, this value here in this equation, and we found this ratio. Theta is equal to pi rad. And 2 pi rad is equivalent to 1 rev and 360 degrees. Teacher, what do you mean by this? We don't understand exactly. Let me show it to you on the graph, right? We have a graph. What does it mean? What does this proof talk about? It talks about what? It talks about, for example, it says when an object, right, traverses an arc length along the circular path and returns to its original position. What does it mean? It traverses let's say, a full circle. It travels the full circle. That's why the arc length is as the circumference of a circle. S is equal to R. S is equal to C. Excuse me. Arc length, right, is as the circumference of the circle. S is equal to C. That's why in this situation, this is called one full circle or one full cycle. Whether you say cycle or circle, no problem. Or one revolution. You can say one revolution or one rev. One full cycle or circle, it doesn't matter. One full cycle is equivalent to what? Is equivalent to, so I'm not gonna, let's say, reveal the answer. Guess the let's say, answer before I reveal it. Think about the angle in degree, right? Whenever you start from here, from the reference line, and this is the let's say zero level reference line. You start from here and you travel the whole, let's say, the whole circle, and you return to its original position. How much is the degree for this path, right? What's the angle of rotation? What's the value of angle of rotation? Actually, the angle of rotation is 360 degrees. So one rev or one full cycle or one full circle is equivalent to 360 degrees and is equivalent to 2 pi rad. So all of these values, let's say, balance one another. Right? Did you understand? I'm sure you understood the subject because I showed it to you on this graph. Let me erase it, and after that I'm gonna, let's say, summarize our speech, and I'm gonna summarize the goal of the proof. What's the goal of the proof? The proof tells us that there's a relationship, there's a correlation between the measurements of the angle, right? What's the, let's say, main, or what's the brief of the conclusion? The main conclusion is one revolution is equal to 360 degree and is equal to 2 pi rad. You see? So we connected three measurements together. Rev, right? Full circle or full cycle. Degree, right? Is the common and old measurement for angle, actually. And rad is a new one, and this one is valid in SI, rad. So we connected between these, let's say, between these measurements. One rev is equal to 360 degree and is equal to 2 pi rad. So they have to do with one another. There's a correlation between these quantities. You can convert, let's say, each of them to the other quantity in next lecture I'm gonna, let's say, focus on the conversions. So what's our goal actually from the proof? I told you in brief we can conclude our result into this equation or into this relationship. 1 rev is equal to 2 pi rad and is equal to 360 degree for a full cycle. For a full cycle, actually. It's true only for a full cycle or for a full circle or 1 revolution. Thank you very much, guys, for this for watching this video, and I want you to follow our next videos.